Alright, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning Godot. I'm hoping today we make some considerable progress. I really wish I would have started the stream like, I don't know, 45 minutes ago, but uh, stuff came up because of which I wasn't able to. Um, and yeah, I'm still hoping that today we are able to stream for at least 2 hours, and I'm hoping that I don't end up spending the next half an hour talking about stuff that I've been working on. That being said, here's some stuff that I've been working on. Yesterday and today as well. Mostly yesterday though. Yeah, for the most part, it was yesterday. I I didn't make too much progress in terms of doing the terminal graphics thing. I'm still exploring the tiny Skia library. I'm still learning my way around the Skia API. I'm so I'm taking help from Gemini for this because tiny Skia itself doesn't have any documentation. I'm guessing because the assumption there is that you're gonna go look at the Skia documentation. The issue is that one, Skia is not a Rust library, so the examples are not in Rust, and two, Skia is a much bigger library that does a lot more stuff than what Tiny Skia does. Tiny Skia was made for a very specific set of goals and it accomplishes those goals very well, right? But Skia itself was made for a much larger set of goals. And yes, it accomplishes its goals very well as well. But if you are trying to learn Tiny Skia, you don't have to learn the entire Skia library. And so if I'm going and looking at examples, I have a feeling that I'm going to be a bit confused. So I don't want to go too deep into examples from Skia. I would probably look at any explanations that they're giving. So far, I know that two things I need to explore, or three things I need to explore. Actually, there's a couple of things I need to explore, but like, I need to explore PixMap, which is our it's the pixel representation of what we are drawing. So it's essentially the pixel map. This is our buffer. Any sort of drawing that you do, it affects this buffer. This buffer is holding the pixel representation of whatever you have just drawn. And another thing I need to explore is the path builder, because that is apparently what you can use to draw shapes. Another thing I need to explore is paint. There's actually a bunch of stuff within paint that I have to explore, and paint and path builder can be used together. I need to explore that part of it as well. Paint itself has a bunch of properties that I need to explore. One of them is shader. I need to see how, and this is what I'm talking about. This is what I mean when I say that there's a lot of stuff that I have to explore within this library, and it makes it a little bit hard that there isn't documentation for Tiny Skia. Um, that being said, you know what I could do? I could create my own little documentation thing for it. I could do that. Oh, actually, something that this is going to sound silly, but something that didn't occur to me until now is to Google Tiny Skia docs and see if someone else has done it. Like maybe someone has done it. Tiny Skia, okay, Tiny Skia, great. Uh, yeah, I'm not seeing, yeah, I'm not seeing any like documentation. Wait, somebody made a crate called Tiny Skia Path. A tiny skier Bezier path implementation provides a memory-efficient Bezier path container, path builder, path stroker, and path dasher. So I'm assuming this is meant to work with a tiny skier. Yeah, this is a tiny skier Bezier path implementation. Okay, all right. Okay, also provides some basic geometry shapes, but they will be moved to an external crate eventually. Let me take a look at um, the repo. Oh, this is by the same person. Okay, branch master was renamed to main. Oh, so is this already merged? Oh, this is by the same developer. That's crazy. This is within the same repo itself. I think at some point in time this was a separate branch, and then it got merged into main. I'm assuming. I'm not sure, but it does say branch master was renamed to main. So I'm guessing that's what happened. Like it was a separate branch, and then it got merged. Um, but yeah, I mean, if that's the case, then yeah, this is done already. Okay, renderer in iced tiny skia. Iced was something to do with GUI, I believe. Let me look this up. Rust iced. I spelled it wrong. And I started off the stream saying that I hope I don't get distracted with talking about the other stuff that I've been working on, and well, 7 minutes in and we are still talking about the other stuff that I was working on. Okay, Iced is a cross-platform GUI library for Rust. A cross-platform GUI library, so and so, so and so, so and so. Um, okay, well, for the time being, I'm not doing GUI stuff, so I don't think I need to look into Iced. Instead, I'm gonna focus on the other stuff. Yeah, okay, so far, this is what I have. I need to, you know what I could do? I could do this, I could update my, what do you call it? My mind map to mention tiny skia or learn tiny skia. And in here, I know I need to focus on pixmap, um, path builder. I don't remember what do you call it? I don't remember what the uh, what the cases were like, as in uppercase, lowercase kind of thing. I don't know what that was in. I don't remember exactly what it was in the code. But yeah, where was okay? So we have path builder, we have paint, we have shader. I forgot where shader comes in. I'm assuming it comes under paint. Um, explore Skia in general um, to understand library possibilities. Oh, another thing I could do, this just occurred to me, doesn't, what do you call it? Rust does docs generation automatically, right? So what I could do is I could Google Tiny Skia here and open it up. Words. I could Google Tiny Skia here and open it up in my browser here, um, and I could look at the auto generated docs. I don't know how much it's gonna help, but it's worth a try. Tiny Skia. There should be a docs.rs thing. Tiny Skia, okay. Let me also open up the repo. Just a second, I'll switch back now. Okay, and we are back. Okay, cool. Let me just make sure there isn't too much lag. I don't think there's too much lag, but let me just like restart the thing just in case, if it helps. Nah, it didn't help too much. It's the regular lag. That's okay though. Okay, so we are done here. Oh, actually, um, look at docs.rs. Okay, cool. Now, what was I gonna do? Oh yeah. So this is the tiny skier. This is the tiny skier library. In here we have. Okay, what is path? Does path have its own like separate thing? Yeah. Okay. Tiny skier path. A tiny skier. Wait, this is not a part of. I don't think this is included in the project, is it? I don't think so. I think I would need to. Okay, under dependencies. Wait, I should look at the dependencies of Tiny Skia itself and see if Tiny Skia path is included. Tiny Skia path is included here. Real quick. Let's open up. I believe it's this. Actually, if I open it here, I think it's gonna be. Oh, bat. Let's do bat. Cargo. .toml. It just shows Tiny Skia. It doesn't show Tiny Skia path. Okay. All right. So if I want path as well, then I need to. Is that mentioned somewhere in the docs? I don't remember it being mentioned. Let's look up. Oh, to be fair, I didn't read the entire thing, the entire README. However, Tiny Skia path is not being mentioned. There's a path here that there's 4 in total. Okay. Out of scope. Advanced Bezier operations. Notable changes. Despite being a port, we still have a lot of changes even in the supported subset. No global alpha. Unlike Skia, only pattern is allowed to have opacity. In all other cases, you should adjust colors opacity manually. No bilinear plus mipmap downscaling support. Tiny Skia uses just a simple alpha mask for clipping, while Skia has a very complicated but way faster algorithm. Okay, I think I might need to experiment by importing this library. I need to see what the exact name is, because, for example, this says tiny-skia. Okay, when I'm saying this, I'm looking at 3 different screens, so I should keep that in mind. In the cargo toml file, which I'm assuming is visible on stream, in this file, you can see it says dependencies tiny skia, but when you're installing it from crates.io or using cargo add, you have to type tiny_skia. So that definitely makes a difference. So I need to see what it says on. Yeah, let's look that up. Tiny-skia-path. on crates.io. So it says that it's passing. So I'm guessing they've done their tests. Uh, oh, you know what else will be pretty convenient when I'm working on my VTuber app and my overlay app and stuff. Rust's or the Rust toolchain's capability to generate documentation automatically, that'll be really helpful. That'll actually be really helpful. Like, that would be incredibly helpful because then I'm not going to have to, sit and write down a bunch of docs. To a certain extent, I might still need to write certain things like make a README or, oh, I should look into in what ways I can customize the auto-generated docs. I don't know if I showed it on stream yet. This is the Tiny Skia crate. On crates.io, um, oh, okay. So it says cargo add tiny skia path. We can do that real quick. Cargo add tiny skia path. Okay, that's done. Then we just do cargo build, and so that I'm not overloading the system, I'll give it 2 cores to work with. Hopefully it shouldn't take too long. Yeah, I think we should be done pretty soon. We are 17 minutes into the stream. I'm trying my best to not get too sucked into this. Wait, TinySkia API is a bit unconventional. It doesn't look like Cairo, Qt Painter, or QPainter, HTML Canvas, or even Skia itself. Instead, TinySkia provides a set of low-level drawing APIs, and a user should manage the world transform, clipping mask, and style manually. See examples, see the examples directory for usage examples, and then this is what we have to work with. So far out of this, I have messed around with PixMap. Actually, I've only messed around with PixMap. There's a bunch of other stuff I need to look into. Yeah, dude. Okay, okay. Um, then we also have, now how do I get to Tiny Skia's crates.io thing without um okay, let me just do this. Actually, instead of doing that, I can do something else. Wait, this is the browser, isn't it? Let's just hide the browser. Yeah, that's better. Okay, now I can look up Tiny Skia path and open up. Okay. So even here it says tiny underscore skia underscore path. But the interesting thing is that I just installed this from crates as tiny hyphen skia hyphen path. Now I'm confused if I used tiny underscore skia or tiny hyphen skia. But yeah, okay. Let's bring back the browser and we can explore this. So this is the Tiny Skia path crate. I also opened up the docs for this. Right. This provides a memory-efficient Bezier path container, path builder, path stroker, and path dasher. Also provides some basic geometry types, but they will be moved to an external crate eventually. Okay. Um, Modules, path geometry, a collection of functions to work with Bezier paths. Okay. All right. I should look into this. I should look into this. This will be interesting. Because I wanted to try and make something dynamic. Um, Initially, I was gonna try using like still images and have that, you know, create the create some sort of dynamicism in the application in the aesthetic. But now instead, I'm thinking I'll actually use tiny Skia to draw what I'm trying to draw and then convert that to terminal graphics. My challenge here is going to be keeping it small enough or keeping it simple enough that actually I'm not going to keep it simple enough. That's the thing. But okay, my challenge here is going to be keeping it optimized well enough that my simple application doesn't end up being really heavy because there's no GPU involved here. It's all going to be CPU based. So I'm going to be relying pretty heavily on stuff like SIMD calculations, for example, or SIMD abilities in a crate. And I'm assuming if I'm using a crate like, for example, noise.rs or noise RS, I'm assuming that there's a fair bit of optimization done there and um, fair bit of thought put into performance and efficiency and stuff. So yeah. If I manage to do this right, then we should have a pretty decent terminal based VTuber application. And at some point later, because initially it's only going to be um, what do you call it? What was I saying? Oh, initially it's only going to be audio reactive. That's the term I was trying to use. I kept blanking on that. I don't know why. Um, but eventually, I also want to try adding not exactly face tracking, but some sort of head and maybe face tracking. Um, Mostly head tracking. I don't know how I'm gonna achieve that because I'm trying to not use um, I'm trying to not use any sort of deep learning model for or basically any sort of body pose estimation model. I'm trying my best not to use any of those because wait, I just realized that it's raining outside and well, I didn't realize that it's raining outside just now, but like I just realized that the sound of the drizzling and stuff like collected water that's falling from one platform to another, that's probably going to be coming through on stream. I didn't take that into account before before I started the stream. Otherwise, I would have actually I don't think I would have closed the window anyways because the reason I opened the window is because I switched off the AC and yeah, there's a little bit of, cold air outside, so I was like, okay, that should be enough to cool down the room. Okay. We are 24 minutes, almost 25 minutes into the stream. We are um hold on. Yeah, we're gonna Um, I think I'll close all of this now. I definitely have a lot to explore off stream, and I should explore a lot of it off stream. Close this, close this. We're going to get into creating instances. Yesterday, we stopped at nodes and scenes. Now we're going to do creating instances. Give me a second. Let me hydrate and then I will start reading. Okay. Um, all right. Wait, before I start reading this, there's an idea that I had for my VTuber application um, head tracking kind of thing. I specifically want something that would track, at least for now, I'm not doing face tracking because I'm not really interested in that. For the time being, I'm specifically looking for head tracking and maybe hand tracking. One option that I have that I might be willing to explore is I make a device using an ESP32 and an MPU 6050 and whatever else I need to use. I'll make a device that does that tracking. It captures the position and rotation in space, in 3D space, and then sends it over to the VTuber application. And in the VTuber application, uh, that position and rotation, it gets applied to the VTuber model in some way. The problem is I don't know how comfortable I would be with uh I don't know how comfortable I would be with having having to wear a head tracker kind of thing. Um, the other option is to use one of the body pose estimation models, but the problem is those are not cheap. They are definitely they can be heavy. So like if I'm hoping to keep things what was I saying? Yeah, if I'm hoping to keep things light and keep things cheap performance wise at least, I don't think adding a body pose estimation model is the best idea. Though there is also the fact that I'm not looking for I'm not looking for I don't know what frame rate I'm trying to go for. I'm happy with 30 FPS. I'm not trying to go for 60 FPS. If what I'm trying to do um works fine in 30 FPS, then I don't need it to be like, super super smooth. As long as I get something that's smooth, I'm okay with that. I'm happy with that. We can look into 60 FPS later on, but at the very least, like baseline is 30 FPS. If I'm able to achieve that, where was I going with this? Why was I talking about the FPS? Oh, yeah. This was to say that maybe this could impact how many times I have to invoke the model to get data. Yeah, yeah. Maybe this could impact how many times I have to invoke the model to get the data. Um, Possibly I could make it so. Oh, Another thing I could look into is limiting what exactly the model is predicting, what exactly the model is generating. Like um, maybe I could limit the model to only provide head tracking, and maybe that might make the model faster. I should look into that. Definitely, I should look into that. I should also look into quantization, to be able to run a smaller version of the model, and see to what extent that impacts the quality of what's being generated. Because what I need is specifically rotation and position. In fact, rotation, I don't know. No, no, no. I need rotation as well. I need rotation as well. I need rotation and position in 3D space, but for now only the head, and at some point later maybe the hands, but not the entire arm. Only the hand portion, like up to the wrist. In fact, only the wrist. I should say that as well. I probably don't even need like the finger landmarks and all, but I mean I could use those landmarks if they end up not being that heavy. Yeah, yeah. Okay. Yeah. I'll see how to approach this. For now, I need to at the very least get this basic program going. At the very least, I need to get this audio visualizer, audio reactive. That's the term I was going for. At the very least, I should try to get this audio reactive VTuber application going, and then I can add the tracking capability on top of that. Okay, right. Let's start reading. So, creating instances. This tutorial refers to instancing scenes in the editor. To learn how to instance scenes from code, see nodes and scene instances. Where is that? Um, okay, that's just a whole separate. Wait, that is under nodes. Oh yeah, yeah, that's a whole separate thing. That's a separate page. Okay, all right. Godot's approach to instancing described below should not be confused with hardware instancing, um, that can be used to render large amounts of similar objects quickly. Yeah, okay. So this is similar to instancing that gets used in Unity, for example. You can group, I believe, objects that have similar materials. I don't remember exactly what the criteria was there, but there's something similar between these objects, that makes it so you are able to uh, get the editor, get the engine to group all of those meshes into one draw call, or like the least amount of draw calls. So this way you don't have a separate draw call for each of those meshes. They can all be grouped into one draw call, and drawn all at once. And that saves you that actually saves a lot of draw calls, thereby improving your frame rate. So in this case, I guess multi meshes is Godot's version of that kind of instancing. And yeah, they're right to point out that yeah, this node and scene instancing should not be confused with that optimization technique. Let's give a quick read to this. For large amounts of instances, in the thousands, that need to be constantly processed, and certain amount of control needs to be retained, using servers directly is a recommended optimization. When the amount of objects reach the hundreds or thousands or reach the hundreds of thousands or millions, None of these approaches are efficient anymore. Still, depending on the requirements, there is one more optimization possible. Multi-mesh. A multi-mesh is a single draw primitive that can draw up to millions of objects in one go. It's extremely efficient because it uses the GPU hardware to do this. The only drawback is that there's no screen or frustum culling possible for individual instances. This means that millions of objects will be always or never drawn depending on the visibility of the whole multi-mesh. It is possible to provide a custom visibility rect for them, but it will always be all or none visibility. If the objects are simple enough, just a couple of vertices, this is generally not much of a problem as most modern GPUs are optimized for this use case. A workaround is to create several multi-meshes for different areas of the world. It is possible to execute some logic inside the vertex shader. Okay, all right. You know what? This is a more advanced topic, so we don't need to look into this right now. For now, we're going to continue with creating instances. Right. In the previous part, we saw that a scene is a collection of nodes organized in a tree structure with a single node as its root. Let's read that again. A scene is a collection of nodes organized in a tree structure with a single node as its root. Okay, a node tree. You can split your project into any number of scenes. This feature helps you break down and organize your game's different components. You can create as many scenes as you'd like and save them as files with the TSCN extension, which stands for text scene. I did not know that. All right. The label.tscn file from the previous lesson was an example. We call those files packed scenes as they pack information about your scene's content. Here's an example of a ball. It's composed of a rigid body 2D node as its root name. Wait, back up. Here's an example of a ball. It's composed of a rigid body 2D node as its root named ball. Okay, so the root node is a rigid body 2D and it's named ball, which allows the ball to fall and bounce on the walls, a sprite 2D node and a collision shape 2D node. So the rigid body 2D node is what gives this its physical properties, such as, gravity, and I'm assuming bounce is also part of that. And then the collision shape is what makes it possible for the ball to actually collide with something, and then the sprite is to just show the ball. It's for the aesthetic. Okay, once you have a scene, once you have saved a scene. There you go. For some reason, I got stuck on that. Once you have saved a scene, it works as a blueprint. You can reproduce it in other scenes as many times as you'd like. Replicating an object from a template like this is called instancing. Okay, as we mentioned in the previous part, instanced scenes behave like a node. The editor hides their content by default. Sorry, zoned out. Okay, the editor hides their content by default. When you instance the ball, you only see the ball node. Notice how each duplicate has a unique name. Every instance of the ball scene starts with the same structure and properties as ball.tscn. However, you can modify each independently, such as changing how they bounce, how heavy they are, or any property exposed by the source scene. In practice, let's use instancing in practice to see how it works in Godot. Give me a second. Okay, yeah. Where was I? Okay, we invite you to download the Balls sample project. Balls sample project. Okay, we invite you to download the Balls sample project we prepared for you. Instancing starter zip. Extract the archive on your computer. To import it, you need the project manager. The project manager is accessed by opening Godot, or if you already have Godot open, click on project, quit to project list. Okay, what if I don't want to download this? Okay, let's continue reading. Let's see. Maybe I could like create my own thing instead of using theirs, because actually I don't know. Yeah, I wonder what the hmm. Okay, something that I could do is wait, where is this stored? GitHub, so and so, so and so, so and so. I could download this and then extract it into my into the project. I could do that. Okay, Godot step by step. I'll just get the I'll find the page that way. Give me a second. I'm just gonna download this thing and then open up Yahtzee and extract it. And then we should have, wait, oh, back up. I don't need to, okay, I need to open up this project like as it is. Do I need this project like other than the sprites? What else do I need the project for? Yeah, I don't think other than the sprites, do I even need the sprites? That's the thing. Oh, this, I believe this already has a ball thing. Yeah, it probably already has the ball scene created. Yep, there it is, ball.tscn. There's a physics material. What if we try to create it manually? Like, um, what would happen? Okay, main, gravity, scenes, instances. Okay, okay. Hmm. Let's read on and see if there's like anything. If I get the feeling that I'm missing something, um, then I'll download it. But I want to see if I can like create this from scratch, because it's not really that complicated, right? I don't know how I would go about creating this, whatever this is. I'm wondering if this is like some sort of path based or curve based thing. I don't know. Let's see. Um, what all did it say? It was suggesting downloading this and then opening. Okay, all right, edit. A window notifying you that the project was last opened in an older Godot version may appear. That's not an issue. Click OK to open the project. The project contains two packed scenes. Main.tscn containing walls against which the ball collides, and ball.tscn. Okay, and ball.tscn. The main scene should open automatically. If you are seeing an empty 3D scene instead of the main scene, click on the 2D button at the top of the screen. Okay, so switch workspaces. Okay, Let's add the ball as a child of the main node. In the scene dock, select the main node. In the scene dock, okay, in the scene dock, select the main node. Then click the link icon in the uh, at the top of the scene dock. This button allows you to add an instance of a scene as a child of the currently selected node. Okay, so these are currently saved. Okay, all right. Double click the ball to instance it. Okay, the ball appears in the top left corner of the viewport. Click on it and drag it towards the center of the view. Press play. Okay, now we want to create more instances of the ball node. With the ball still selected, press Control D. All right, that's to duplicate. Okay. You can repeat this process until we have several in the scene. Play the game again. You should now see every ball fall independently from one another. This is what instances do. Each is an independent reproduction of a template scene. All right. Editing scenes and instances. There is more to instances. With this feature, you can change the properties of one ball without affecting. You know what? Back up. Here's what we're gonna do. Okay, I'm gonna create a new scene. Make this a 2D scene. We're gonna. How do I? Is there a shortcut to like rename? What is it? F2. Okay. Uh, yeah. Let's stick with the theme. Main. Prefer this casing. What is more common in Godot? Yeah. Let's stick with this. Let's stick with this. So this is our main scene. Okay, we're gonna save this as main.tscn. Then we're gonna create a new scene. This is gonna be also 2D scene, but we're gonna call this ball. Um, oh, no, this is not supposed to be. This is supposed to be a rigid body 2D. Right, and then we call this ball. Are there physics properties on this? Where's that, what was it, physics material thing? Oh, good, there's a search thing there to be able to find the properties so you don't have to like scroll. Okay, so we need a physics material here. All right, we have a physics material. Collision. This. Okay, what is this saying? Node configuration warning. Yeah, this doesn't have a collider so far, right? This node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. All right, so first of all, we can add a sprite 2D for its aesthetic. Give me a second here. Let's do that. And so, oh wait, I just realized there's nothing to like look at the that there's nothing for us to be able to look at in terms of aesthetics. Okay, so for the texture, let's go for, do they have like procedural shapes? What is a good one? Curve texture, mesh texture. I could just go for a gradient. For now, I can't think of something that would give me a circle texture because there is a curve texture, but I'm not sure what exactly that does. Like, do I have to? Okay, a 1D texture where pixel brightness corresponds to points on a curve. Image texture. Okay, okay. We can just go for a gradient. That's fine. All right, now, um, what is the size of this? Maybe a 1D texture is not. Maybe a 1D texture is not a good idea. Let's go for 2D. Yeah, much better. Now we move this here. Actually, should this be in the center? I should look into that. Does that make a difference? I don't think it should make a difference, but it's worth exploring. Like where exactly does the object end up? Because what we are doing is we are saving this scene, right? And then we are dragging and dropping this scene into another scene to make it a node in that scene's node tree, right? So if it is reading the scene and the root node's position is not at 0 in the scene, does that mean that it's not going to be centered? Or is Godot smart enough to read the? I don't think it's about Godot being smart. That's a wrong way to put it. Um, is it such a thing in Godot that it will it will read the root node's position rather than um, reading the scene's the scene world's center position. Because if it reads the scene world's center position and not the root node's position, then it'll be like, okay, we have a container, and this container has a root node inside, but that root node's position is separate. So then you have a sort of like a pivot kind of situation going on. Um, that would be interesting to experiment with. I can create like a ball O2 and have that kind of a setup and see how well it works out. Also, this is not going to be a ball. It's going to be, well, it's going to be a square ball. How do I do that, dude? Hold on. I need to check with Gemini if Godot has any built-in tools. Hey, I'm new to Godot. Um, I'm learning 2D stuff in it. I'm wondering if there is a way to create a simple circle sprite. Okay, in Godot sprites, you usually expect an external image. However, you have three great ways to make a circle without opening Photoshop or Blender. The quick and dirty way, the placeholder texture. If you just need a circle for testing, you can use a standard sprite 2D node with a built-in texture. Add so and so. Okay, find the texture property. New placeholder texture. Set the size to 64 by 64. Note this will be a square. To make it a circle, you'd actually want the next method. This is the fastest way to get something, quote unquote, on the screen. The clean way is to use a color rect with a shader. If you want a perfectly smooth, scalable circle, use a color rect and a tiny bit of code, a shader. This is a pro way to do it. Wait, hold on, dude. Why is this so complicated? Well, it's not really complicated. It's just that it's not the most straightforward thing. I think there might be a quicker way to do this. I think I just need to do proper googling to get it. So here's what we're gonna do. Okay, our ball, quote unquote, is gonna be a square. We're gonna make a collision shape 2D. Or was it circle collider? I think it's collision shape 2D. And then within that, I think you can select the shape. Right, so what all do we have? We have world. Sorry, the right side of my screen is being obstructed or occluded by my camera stand. My my what? My camera stand. I don't know what I just said. Okay, yeah. It's being obstructed by my camera stand, and that's why I'm having some trouble reading it. Okay, world boundary shape 2D, segment shape 2D, separation shape 2D, circle shape 2D, rectangle, capsule, convex polygon, concave polygon. Okay, so we'll go with circle shape. Okay, all right. This is our shape. How do we wait? Do I have to switch this on? Okay. Now, how do I control the properties of this? There, radius. I think that's good. Yeah, that's enough. Okay, all right. Now we can save this as ball dot. Oh, the name was already there. Right, ball.tscn. Then we go into main, and in main we can create a bunch of. So let's create a child node, and this can just be a collision shape, can't it? I think so, because the shapes, the walls, they don't need to have rigid bodies on them. Usually when there's um, physics collisions happening, it's only one of the bodies that needs to have a rigid body attached to it. Both of them don't need to have rigid bodies. Okay, collision shape 2D. I guess that could be our, or should the sprite, maybe the sprite should be the, okay, this would be called wall. Okay. Give this, oh, you know what? I could have just used this icon. But yeah, let's do gradient texture 2D. Wait, what's wrong? Why is there an, why do we have an error here? That's weird. Wait, did I click on something wrong? Why is this showing up like this? Okay, it's not that. Hmm. Is there already like a texture on this? This is a sprite 2D. Yeah, no, I'm not entirely sure. Also, I like that we can edit this gradient. Oh, was I supposed to edit the gradient? That's crazy. I need to explore this more to understand what happened. Anyways, so then what are we doing next? We are then applying a collision shape 2D, and this is going to be a rectangular thing or a rectangle. All right. Let's increase the size. I think we can just double it, right? Oh, too much. Triple it. Yeah, let's triple it. It's not exact, but it's close. It's very close. Now, what I'm wondering, wait, what is this saying? Collision shape 2D only serves to provide a collision shape to a collision object derived node. Please only use it as a child node of area 2D, static body 2D, rigid body 2D, character body. Okay, all right. Let's try something here. So let's create a static body 2D, and then put this wall under this. Actually, then this would be sprite 2D. We would call this wall, and let's also bring this here. Great, awesome. Wait, can we change the order here? Yeah, we can. Okay, all right. Okay, great. So now we should be good. And in here, dude, I wonder if there's a way for me to like export this one thing. Like, let's say I've created a node tree. Oh, is it this? Save branch as seen. This might be it. This might be it. Yeah, let's open up wall. Where's wall? Why is wall not opening up? Okay, that was odd. Anyways, this is wall, and here what we can do is um try and scale this up. This is rotation, this is scaling. So let's scale this. Okay, good. So the scaling applies to um, the children as well. Awesome. So now we can rotate and hold on. Where is our? This is our scene. Okay. Um, we're in rotate right now. We're still in rotate. All right. So we have that. Then we can uh, rotate this. That is scaling. Rotate this. Hold on. Something looks odd about this. Yeah, something seems odd about this. This doesn't even seem like the same size. Is it the same size? Oh, this is panning. I just by fluke, by just coincidence, I hit this key. So this is pan mode. What is this? Ruler mode. What does that do? Oh, that's convenient, dude. Yo, no, that is convenient. Backup. That is really convenient. I should remember that this is a thing. What is this? Show list of selectable nodes at, at positions clicked. I don't know what this does. Okay, what is this? Click to change object's pivot. All right, I'll play with that later. For now, we need to rotate. Nope, we need to. Oh, that's what the problem was. Because when you scale, when you, so this is something I've noticed in Godot. For example, if I try to move this object, let's make sure we're in move. Is this a good example? This is not a good example. I think scaling would be a better example. Okay, I'm trying to, yeah, this is one of the examples. Sometimes it actually I need to figure out exactly in what situations it's doing this, but I've noticed it doing this in the case of moving as well. Just now for some reason it didn't do it, but I've noticed it doing this in the case of moving as well. Where you try to move and there's going to be multiple move operations. So you can see over here, there are two move operations, move from so-and-so to so-and-so and move from, actually it's just move to so-and-so. So it's move from whatever position it's at to whatever new position. And because of that, if let's say you've moved from here to here, if it has recorded multiple move operations, then when you undo, it's going to go back to one of the previous operations. So it's like it's undoing in steps. It doesn't exactly undo back to that location. Anyways, that's why we had that bit of confusion. So I'm gonna do this and then come here and rotate. Okay, great. And then let's create another duplicate and rotate and come here. All right, now we can drag the ball in here, the quote unquote ball. We can scale it up. Oh, all right, yeah. So we can save our main scene and run this. Is this going to work? I'm not sure if this is going to work. Also, there seems to be an error. Let's, well, not error, but there's some sort of warning here. Size changes to rigid body 2D will be overridden by the physics engine when running. Change the size in children collision shapes instead. Okay, that complicates things a tiny bit. But yeah, for now we can just do this. I'm kind of confused about why we are only seeing this much when the scene is supposed to be, I'm assuming, this area. This area is supposed to be the scene, but it's only showing like maybe this much. Oh, you guys can't see it. I just realized that. Well, I can't really do too much about that for now. I haven't set up that like extra source so that OBS can capture it. Um Okay. Uh, right. How do I go about? Because I was assuming that this is gonna be our scene, like this area, but for some reason it's not. Yeah, that is weird. That is definitely weird. What if I add a camera to this and we bring the camera here and then run this? Now it's showing, oh God, dude. Wait, this is interesting. Okay. All right. So we'll bring this here, run. Why does it look like this? I've done something wrong somewhere and I'm not sure exactly where I've gone wrong. I don't think I need this camera, but I am definitely confused about why I'm not seeing. Oh, what if I close this? Okay, now I see a little more. Keep aspect ratio of the embedded game is selected. What if I select this? Okay, this might be better. Okay, okay. So our collision didn't really work. Yeah, the collision didn't happen. What if we do this? Nope. Still nothing. Okay, are there any things I need to and words? Are there any properties here that I could look at that, because like, okay, editing the scenes, okay, change so and so, changing a property on an instance always overrides values from the corresponding packed scene. Let's try this. Double click this in the file system to open it. In the scene on the left. Okay, then in the inspector, right click the material to expand it. No, on the right, click on the physics material property to expand it. Set its bounce property to zero point 0.5 by clicking on the number field by typing 0.5 and pressing enter. Um, okay, let's now adjust an individual instance. Head back to the main scene by clicking so and so. Okay, select one of the instanced ball nodes, and in the inspector, set its gravity scale to 10. Okay, for the time being, I need to figure out why this collision is not happening. Let's move this ball here. Let's um, select these. Let's select these, and okay, select these, and now move this up here. So at least I'm able to see it when I run this. Okay, so It is falling right through. Am I missing something here? So let's take a look at ball. Wait, what is this disabled property supposed to be? Hold on, let's go over it again. A disabled collision shape has no effect in the world. I thought this was enabled. Why did I check this? I think I just saw on, and so I thought it means collision on. I think I didn't see the I think I didn't see it saying disabled. Okay, now it's colliding. You guys cannot see it. Actually, I wonder if you can see it in, no, you can't see it in the workspace. In the game view, you guys actually can't see the game view right now. Wait, are you able to see? No, you're not. All you're seeing is what do you call it? Is a gray screen. I need to find a way to get that that screen to be captured. You know what? Okay, let's run this, and temporarily I will go into OBS and create a new capture source, screen capture pipe wire, Godot debug, WinCap. Okay, debug, share. Oh God, is it glitching on screen as well? I don't think so. Hopefully not. Yeah, it's not. We're good. Okay. So this is what the game view looks like right now. Yeah, that's what the game view looks like. I could actually turn the size down. The size doesn't have to be that big. I could make the size smaller, just for the sake of showing it. I don't know what's going to happen to it once I exit this. It is stuck. Okay, it is stuck, which is fine. However, let's now run this again. Okay. So that's our, now I wanna see if this shows up on stream. I think it should. I want to see what happens once once I rerun the build. Okay, give it a second. Uh, it's not capturing. Yeah, it doesn't capture the thing again. I have to go back into OBS and repoint it to the thing that I wanted to look at. Okay, so I'm gonna have to find a better way to do this, which is okay. However, we have we've accomplished the thing that we were trying to accomplish. So there is a lot more experimenting for me to do here, which I guess I'll do off stream. For now, though, we'll continue reading this. Okay, this icon indicates you are overriding a value from the source packed scene. Even if you modify the property in the original scene, the value override will be preserved in the instance. Clicking the revert icon Wait, no, no, back up. I'm reading it, but I'm not really understanding or I'm not really paying attention to what I'm reading. Okay, even if you modify the property in the original scene, the value override will be preserved in the instance. Oh, okay, okay. All right, now I get it. Clicking on the revert icon will restore the property to the value in the saved scene. Rerun the game and notice how this ball now falls much faster. All right, cool. Actually, instead of gravity, I I want to increase the bounce. I want to increase the bounce to. Hold on, why am I not able to? Oh, is the physics material a separate thing? I think it's because of that. Yeah, I think it's because the physics material is a separate thing. Is the game running? I don't know, it's not running. Go into the ball, collision shape, ball, okay. Okay, well this is not gonna do what I was trying to do. Instead, where hold on, where did it create that the physics material? Because it seems to have created the material, but like I don't know where the material is. Okay, it's here. What we could do is clear that and add a new physics material. I don't, wait, this is like a default physics material. Okay. Uh, right. Okay, you know what? What I was hoping to do was create different instances of this ball and then give it different bounces. But it seems like I can't do that. I can probably do that on other properties here, but I can't do that for this specific thing. So I could I could do it for the gravity scale. So like let's create a duplicate and bring it here, and then see how quickly one falls and how slowly the other falls. So yeah, okay, we'll do. Wait, why did that thing just disappear? What happened there? Okay, let's do 0.1, I guess. That should be slow enough. Um, you guys won't be able to see it. I'm just gonna have to describe to you that hey, this is how it's happening. So yeah, the second quote unquote ball fell much slower than the first one. I'll have to find another way to do. I know there's another way to like have different instances have different, you know, bounce values. I just haven't figured it out yet. Because if we go into ball here, okay, there's a make unique thing. Okay, wait, let's do that. What does that do? Set physics material override. Okay. In that case, wait, let's come here and set this one to be a unique one. Okay, all right. Now we are able to do it. Now we are able to edit this. So I need to look into the unique thing. Um, okay, select these, bring them up. Okay, save. Oh, we don't have too much of a bounce going on. So first of all, let's crank up the bounce. Let's also crank up the gravity. I actually bring the gravity back to. Ran the wrong scene. Okay. All right. Okay. Cool. We have some bounce. We have some bounce going on as well. Oh, just so happens. Oh my God, you're joking. You are joking. You know what's funny about this? I have been trying to mess around with this, trying to change the bounce this entire time, and trying to mess around with the physics 2D with the physics material. And it just so happens that in the browser, I was looking at this note, but I hadn't read it yet. I hadn't gone into reading it yet. This solves the exact thing that I was trying to solve. That's crazy. Okay, anyway, so it says note. You may notice you are unable to change the values of the physics material of the ball. This is because physics material is a resource and needs to be made unique before you can edit it in a scene. Before you can edit it in a scene that is linking to its original scene. To make a resource unique for one instance, right click on the physics material property in the inspector and click Make Unique in the context menu. Resources are another essential building block of Godot's games we will cover in a later session. How come the resource is not showing up here? I'm curious about that. Like how come the resource doesn't show up here? Um yeah. I'm curious about like how come it doesn't show up here? Is it meant to be tied to something? Like is the physics material supposed to be tied to a specific node? So that's why over here we are able to make it unique, and then this instance has its own physics material, whereas the original instance or the original scene has its own physics material, and the engine is just keeping track of all of them as, belonging to either an instance or a scene or whatever, and then we are not able to select. Actually, I wonder, wait, yeah, no. If I, let's say I create, what's the shortcut for this? A, Control A. Okay, let's say I add a rigid body 2D node, sum O1. This is actually a perfect time to do this. Sum body O1. Because I like using sum in variable names and stuff, so this is a perfect. Yeah, anyways. Sum body O1. In here we want to put a collision shape 2D just so it actually collides. Okay, this tripped me up the last time because it said disabled here, right? I didn't read disabled, but I saw a checkbox saying on and it was unchecked. So in my mind, it was like, oh, for some reason, this collision shape is off by default. So I have to switch it on by checking the on checkbox. In reality, the on checkbox was to turn on the disabled property. That is crazy. That is crazy. Anyways, what was I gonna do here? Oh, I was gonna check if. All right, so we do have a physics material over here, one that was made for a separate scene. However, I'm not seeing the unique version that we created here. Also, is there a unique thing here as well? Oh, now this is unique as well. Hold on. Does that mean that it's unique here? Okay, what if I do this? What if I do this and come here and save this? Now let's say I bring in an instance of this. Okay, no physics material. Run this. Okay. I'm a bit confused here because in that case, it seems like make unique is essentially a flag which makes it so every instance of this node, every instance of this scene, which happens to have this physics material, will be unique. Can we disable the uniqueness? Yeah, how do we disable the uniqueness? Let's okay. So we've done this, right? Let's go back to the override. Sorry, not override. Go back to the what do you call it? Whatever the original is, and then ball. Okay, all right, that's good. Now, here we select this and save, and then come here and let's select ball. Okay, it's not unique anymore. It's not unique. It's not unique anymore. We have freshly set the thing. When you freshly set it, apparently it's not unique. You can then, okay, is there any documentation or any like help tooltip or something? Okay, I'll read up on this later. So now I've made this unique. Now that I've made this unique, I can have individual properties being set. No. Okay. All right. So for these, we are not able to do it, but for this one ball instance, we are able to do it. Okay. One last thing I'm going to try because in the previous iteration, I had gone into this, I'd gone into the original scene, in the original scene's node tree, and I had clicked make unique here. So I want to see what happens if I make this unique and then save it and then come here. Yeah, that's crazy. Now we are not able to make it unique. Or now I should say now it's not automatically becoming unique. Previously it did, or maybe I was just remembering wrong. I don't know. Let's try bringing in another ball and see if that's unique. Yeah, this one it's not unique. The unique thing applies to the individual instances. I don't know how I did it how it words. I don't know how I did it previously. Um but yeah, yeah. Okay. Moving on. I definitely need to read up more on the make unique thing. But yeah, moving on. Scene instances as a design language. Instances and scenes in Godot offer an excellent design language. Instances and scenes in Godot offer an excellent design language, setting the engine apart from others out there. We designed Godot around this concept from the ground up. We recommend dismissing architectural code patterns. We recommend dismissing architectural code patterns when making games with Godot, such as model view controller or entity relationship diagrams. All right. Instead, you can start by imagining the elements players will see in your game and structure your code around them. For example, if you could break down a shooter game like this, like so, why did I say if? For example, you could break down a shooter game like so. We have the stage. I'm assuming that is our main scene. Then we have the weapon, the missile, the enemy. Um, this is interesting. So, okay, the stage has a player ship, an enemy, an obstacle, and a HUD. Oh, and another enemy. Then that other enemy can instance a missile by code in the main scene. The player ship has a weapon which can also instance a weapon in the main scene. I'm not sure what the connection is between market and HUD. I guess market is another entity, right? It's a separate entity, and um, it is updating the HUD. I guess that's one way to look at it. Okay, you can come up with a diagram like this for almost any type of game. Each rectangle represents an entity that's visible in the game from the player's perspective. The arrow points towards the instantiator of each scene. The arrow points towards the instantiator of each scene. Oh, so the stage is instantiating the missile, and the enemy. That doesn't make sense. The missile is instantiating the enemy there? No. The arrow points towards the instantiator of each scene. Did they say that wrong, or am I understanding it wrong? Because to me it seems here like enemy instantiates missile, which makes sense, right? Because the enemy is firing the missile, and then missile is being instantiated in stage. That Okay, maybe I shouldn't be looking at the gray arrow. Maybe I should just be looking at the blue arrow. Okay, let's continue reading. Once you have a diagram, we recommend creating a scene for each element listed in it to develop your game. I need to feed that image into Gemini and ask Gemini to um, analyze that and explain it to me, specifically in Godot architecture terms. Okay, once you have a diagram, we recommend creating a scene for each element listed in it to develop your game. You'll use instancing either by code or directly in the editor to build your tree of scenes. Programmers tend to spend a lot of time designing abstract architectures and trying to fit components into it. Designing based on scenes makes development faster and more straightforward, allowing you to focus on the game logic itself. Okay, because most game components map directly to a scene, using a design based on scene instantiation means you need little other architecture code. Let me read that again. Because most game components map directly to a scene. Okay, most game components map directly to a scene. Using a design based on scene instantiation means you need little other architecture code. Here's an example of a scene diagram of an open world game with tons of assets and nested elements. So we have the terrain, um, we have a vase, on a table, in a room, which is in a house, which is in a citadel, which is on terrain. Okay, the room also has a chair, the house also has a door, the citadel also has a church, or is also a church. The terrain also has a bridge, the bridge also has a guard, the church also has a seat. Okay, the terrain also has a player, and the player also has the HUD. I am slowly starting to understand this diagram, but like I really need to I need to spend some time trying to wrap my head around this. Okay, imagine we started by creating the room. We could make a couple of different room scenes. You know what? Okay, one thing that I do understand is that each and every one of these elements needs to be a scene. And the interesting thing about that is further from that point, they can all be like mixed and matched because each of them is a scene. They can all just go inside each other. Um, where was I? Yeah. Imagine we started by creating the room. We could make a couple of different room scenes with unique arrangements of furniture in them. Later, we could make a house scene that uses multiple room instances for the interior. Okay, we would create a citadel out of many instanced houses and a large terrain on which we would place the citadel. Okay, each of these would be a scene instancing each of these would be a scene instancing one or more subscenes. Later, we could create scenes representing guards and add them to the citadel. They they would be indirectly added to the overall game world. Hold on. Later, we could create scenes representing guards and add them to the citadel. They would be indirectly added to the overall game world. Okay. So the overall game world is more of like a conceptual kind of thing in this specific instance, I'm guessing. Because when you say overall game world, no, it's not. It is the actual thing because the citadel is on the terrain, right? So if we add guards to, so here it's mentioning guards on a bridge which is on the terrain, which technically also it's the same concept as in the sense that um, the guards are still becoming part of the overall world. The overall world is all of this. The overall world is essentially whatever is inside terrain. All right. With Godot, it's easy to iterate on your game like this, as all you need to do is create and instantiate more scenes. We designed the editor to be accessible to programmers, designers, and artists alike. A typical team development process can involve 2D or 3D scenes, level designers, no, sorry, 2D or 3D artists, level designers, game designers, and animators, all working in the Godot editor. Summary. Holy shit, we are at the end of this. Hell yeah, dude. Summary. Instancing is instancing the process of producing an object from a blueprint has many handy uses. With scenes, it gives you the ability to divide your game into reusable components, a tool to structure and encapsulate complex systems, a language to think about your game project's structure in a natural way. Awesome. Great. So we are done with this, and now we are moving on to the next thing, which is scripting languages. So we're going to be reading up on all the scripting related stuff. Well, whatever scripting languages are supported, and their pros and cons. I was about to say we're going to be reading up on all the scripting related stuff, but that's not entirely true. We're going to go into actual scripting in the next chapter, which is creating your first script. And this is exciting because this is where we're going to bring Rust into Godot, because we're going to be learning this side by side with this, which I didn't load before the stream. Actually, not this. Um, hold on. Not that one. This one. So we're gonna be reading that other page, the creating your first script page, alongside this page. So wherever Godot, wherever GD script is supposed to come in, we are instead going to be using Rust. I think a good portion of this stuff I've already done in terms of like creating the project structure. Maybe there's a last part remaining. I don't remember if I created the GD extensions file. I think that part is remaining. Other than that, well, actually, everything after this, like, basically this wire up Godot with Rust. I haven't done anything from this point. Anything further I haven't done. All right. So, scripting languages. This lesson will give you an overview of the available scripting languages in Godot. You will learn the pros and cons of each option. In the next part, you will write your first script using GD script. Scripts attach to a node and extend its behavior. This means that scripts inherit all the functions and properties of the node they attach to. All right. For example, take a game where a camera 2D node follows a ship. For example, take a game where a camera 2D node follows a ship. The camera 2D node follows its parent by default. Okay, I'm reading it, but I'm not really understanding it. Let me restart again so I'm actually paying attention to what I'm reading. For example, take a game where a camera 2D node follows a ship. The camera 2D node follows its parent by default. Okay. Okay, all right. Imagine you want the camera to shake when the player takes damage. As this feature is not built into Godot, okay, as this feature is not built into Godot, you would attach a script to the camera 2D node and code the shake like this. Okay. Available scripting languages. Godot offers 4 gameplay programming languages, GD script, C#, and via its GD extension technology, C and C++. There are more community-supported languages, but these are the official ones. Okay, you can use multiple languages in a single project. For instance, in a team, you could code gameplay logic in GD script as it's fast to write, and use C# or C++ to implement complex algorithms and maximize their performance. Once you write everything in GD script, or you can write everything in GD script or C#, it's your call. We provide this flexibility to answer the needs of different game projects and developers. Okay, which language should I use? If you're a beginner, we recommend to start with GD script. We made this language specifically for Godot and the needs of game developers. It has a very lightweight and straightforward syntax and provides the tightest integration with Godot. For C Sharp, you will need an external code editor like VS Code or Visual Studio. While C Sharp support is now mature, you will find fewer learning resources for it compared to GDScript. That's why we recommend C Sharp mainly to users who already have experience with the language. Let's look at each language's features as well as its pros and cons. Okay, GDScript. GDScript is an object-oriented language and is an object-oriented and imperative programming language built for Godot. It's made by and for game developers to save you time coding games. Okay. Its features include a simple syntax that leads to short files, blazing fast compilation and loading times, tight editor integration with code completion for nodes, signals, and more information from the scene it's attached to. Built-in vector and transform types, making it efficient for heavy use of linear algebra, a must for games. Supports multiple threads as efficiently as statically typed languages. No garbage collection, as this feature eventually gets in the way when creating games. The engine counts references and manages the memory for you in most cases by default, but you can also control memory if you need to. And gradual typing. Variables have dynamic types by default, but you can also use type hints for strong type checks. All right. GDScript looks like Python as you structure your code blocks using indentations, but it doesn't work the same way in practice. It's inspired by multiple languages, including Squirrel. I didn't know that was a language. That's crazy. But to be fair, when brainfuck can be a language, then Squirrel can be a language as well. Squirrel, Lua, and Python. Why don't we use Python or Lua directly? Years ago, Godot used Python, then Lua. Both languages integration took a lot of work and had severe limitations. For example, threading support was a big challenge with Python. True. With Python, you have that whole guild situation, which makes multi-threading a little more complicated. Developing a dedicated language doesn't take us more work, and we can tailor it to game developers' needs. We are now working on performance optimizations and features that would have been difficult to offer with third-party languages. Okay, .NET/C#. As Microsoft C# is a favorite amongst game developers, we officially support it. C# is a mature and flexible language with tons of libraries written for it. We were able to add support for it thanks to a generous donation from Microsoft. That's awesome, dude. C# offers a good trade-off between performance and ease of use, although you should be aware of its garbage collector. Note, you must use the .NET edition of the Godot editor to script in C#. You can download it on you can download it on the Godot website's download page. Okay. Since Godot uses .NET 8, in theory, you can use any third-party .NET library or framework in Godot, as well as any common language infrastructure compliant programming language, such as F#, Boo, or Clojure CLR. I'm assuming it's Clojure, as in the J is meant to be like je. Anyways, however, C# is the only officially supported .NET option. Note, GDScript itself doesn't execute as fast as compiled C# or C++. However, most script code calls functions written with fast algorithms in C++ code inside the engine. In many cases, writing gameplay logic in GDScript, C Sharp, or C++ won't have a significant impact on performance. Attention, projects written in C Sharp using Godot 4 currently cannot be exported to the web platform. To use C Sharp on that platform, consider Godot 3 instead. Android and iOS platform support is available as of Godot 4.2, but it's experimental and some limitations apply. To learn more about C Sharp, head to the C Sharp/.NET section. Then C++ via GD extension. GD extension allows you to write game code in C++ without needing to recompile Godot. You can use any version of the language or mix compiler brands and versions for the generated shared libraries thanks to our use of an internal C API bridge. GD extension is the best choice for performance. You don't need to use it throughout an entire game engine, as you can write other parts in GDScript or C Sharp. When working with GD extension, the available types, functions, and properties closely resemble Godot's actual C++ API. Alright, summary. Scripts are files containing code that you attach to a node to extend its functionality. Godot supports 4 official scripting languages, offering you flexibility between performance and ease of use. You can mix languages, for instance, to implement demanding algorithms with C or C++, and write most of the game logic with GDScript or C Sharp. In our case, I'm going to be writing everything in Rust, mostly because I want to, and it'll also give me more practice of doing Rust related things in Godot. Yeah. Okay, so we've made some pretty great progress today. That's pretty awesome. And I'm excited to jump into the next section, which is creating your first script. That being said, give me a second here. Okay. All right. What's going on here and here and here? Okay. Who should we go to? Um, Wait. Hold on. You know what? Yeah, we're gonna actually no. Hold on. Hold on. Okay, what's going on here? You know what? Yeah, I think I'll head over to this person's stream. So their name is Toriette. I'm not sure if I'm pronouncing that right. Let me see if I'm even able to send a raid there. Yes, I am. Okay. So, that's gonna be it for today's stream. We made some good progress today. Some pretty awesome progress. I'm gonna pause this here. I'm not gonna I'm not gonna continue with this off stream. Tomorrow we're gonna start with this very same tutorial section tomorrow. And yeah, tomorrow we're gonna start doing actual Rust with Godot. So that's exciting. That should be fun. Off stream, I'm gonna continue doing stuff with Tiny Skia and mainly Tiny Skia actually. Trying to draw shapes and stuff and learning how to use the library. And once I get a hang of it, then I can write my very simple translation layer to translate this stuff into something that can be consumed by Ratatouille and then displayed in the terminal. Okay. But yeah, my raid timer is running out. So that being said, that's gonna be it for today. I hope you guys have a nice day, and I'll see you all next time. Peace.